Chapter 30 problems, and I will not be explaining a lot here. Okay. Magnetic field due to a solenoid from which you find the flux. Flux is always magnetic field strength times the area. From that you can find out the self-inductance of a solenoid. Formula is mu naught n squared A by L. So all quantities given, 0.022 Henry. Now if you change the material, then the permeability changes, so I must not have it as mu naught. This time the permeability is that of iron, and it is 1200 times that of air. So it's 1200 times 4 pi times 10 to the negative 7 times the area, which is pi r squared. Gives you 81 tons. So question number 2. That's the formula for increase or growth of current in an LR circuit, which you rearrange to make tau the subject. That's the time constant. Now you reverse or take 1 by of each side, that's why you get that, and then exponential on the other side becomes natural log, 1.85 milliseconds. In the B part, remember that tau is L by R, 31 millihenry in milliseconds, so really they'll cancel out. You get 16.8 ohms. Question 3. Inductive reactance is 2 pi FL. So that's a frequency in kilohertz, so change it into hertz. 7532 ohms. Therefore the voltage, I times the reactance. For current, 0.0332 ampere. Number 4, XC, that is capacitive reactance, is 1 by 2 pi FC. (2804 ohms). The RMS current is always the RMS voltage by XC. And peak is square root 2 times the ARMS. (11 amperes), and of course the frequency does not change, so whatever is the frequency of the voltage, the same will be the frequency of the current. Number 5, impedance given, and inductive reactance. We've got to find the resistance. Impedance is XL squared plus R squared square root in an LR circuit, so rearrange to make resistance a subject. (192.35 ohm). Number 6, the impedance in an LCR series circuit is square root r squared plus xl minus xc whole squared. Now, it's always good to separately and individually calculate these and then plug it into the formula. There's less chance of making mistakes. xc and therefore now we can substitute all that as resistance squared plus these two numbers. Take the difference, doesn't matter if it's negative because when you square it, it becomes a positive. Now the phase difference, tan phi, is xl minus xc by the resistance. Take the tan inverse of that and you get negative 3.52 degrees. Now the RMS current is again Vrms by the impedance. 8.32 times 10 to the negative 2 ampere. Seventh question. Resonant frequency is given by 1 by 2 pi square root. Now rearrange that. Of course, you square both sides and separate the C and you get the A part. And B, at resonance, the impedance is a minimum and it becomes equal to the resistance. And to find the peak current, always use the peak voltage divided by the resistance. Why? Because at resonance, the total impedance becomes equal to the resistance. So you get the peak current. The last one, inductive reactance is 2 pi FL. 13.19 ohm, and capacitive reactance is 1 by 2 pi Fc. Now impedance is this square root r squared plus xl minus xc whole squared. .83 ohm. Again, to find the IRMS, it's Vrms by Z. That gives 0.51 ampere. B part, you've got to find tan phi. It's XL minus XC divided by the resistance. Get us negative 88.7 degrees. And finally, power, average power is I squared RMS times R. 0.51 watts. Okay.